Hello there, and welcome to this video on the general form. Now, when I hear the word general, to me that kind of makes me think of, say, like the army. If you had a general in the army. So that's what I want you guys to think of. Because in the army, you want everything lined up, you want it really proper, you want everybody in nice neat rows, and that's kind of what general form is. So for a linear equation, it's going to be everything all lined up nicely on one side of the equation and then equals 0 on the other side. So that's why I want you to compare it with general in the army. So they're all lined up nicely on one side. So we got ax plus by plus c equals 0. And a, b, and c, these are just going to be different numbers. There are some requirements though. A and b cannot both be 0. One of them could be 0, but not both. And a has to be a whole number. So that means it has to be a positive integer. So it's got to be like a 1, a 2, a 3, and so on. It can't be anything negative, and it can't be a fraction. So if ever a is negative or a fraction, you have to alter it so that it is not. So looking at our first examples here, it says rewrite the following equations in general form. So we want to get it to look like that type up top. So I need everything all lined up nicely on one side. So I'm going to do that first. I'm going to move everything to the other side. And whenever you move something to the other side, the sign is going to change. So this is going to become a positive 2/3 x. And then we had a y over there, so we got plus y. And then when the 6 comes over, it was positive, but now it's going to be negative. And then don't forget, you got to have equals 0. So now that everything's lined up on that side, we almost have general form, but this a value in front, right, a went with the x, that one we currently have a fraction, and we said we couldn't have a fraction, and it also couldn't be negative. So we got to somehow get rid of this fraction. So they have a divide by 3. The way we could get rid of a divide by 3 is to just do the opposite and multiply by 3. So I'm going to multiply by 3 there. But then I have to do it on every other term. So this one is also going to get multiplied by 3, and then the 6 is also going to get multiplied by 3, and even the 0 has to get multiplied by 3. All of them get multiplied. So in the first one, they're going to cancel. So we only have the 2 and the x, and then with the next one, 3 times y is 3y. Then we had minus, 6 times 3 is 18, and then we got equals, 0 times 3 is 0. So that is our general form. We got the a x plus b y plus the c value, which is actually a negative 18. So number 1 is now done. If you want to try to do number 2, you can pause the video now and try to do number 2. So first step, what I'm going to do, I'm going to move everything to the other side. When they move over, the signs are going to change. So this is now a negative 3/4x, and I'm putting the x first because we should have x first in our general form. Then we had a y that was positive. It doesn't change sign because it was already on that side. And then the negative 2, when it moves over, it's now positive 2, and then we have equals 0 because there's nothing on that side anymore. So now we got to get rid of the 4 here. We can't have any fractions, and there's a negative. So first I'm just going to get rid of the 4. So to get rid of a divide by 4, I'm going to multiply by 4 and then do that on all the other ones as well. So they all get times by 4. And in the first one, that one cancels out. So I have negative 3x plus 4 times y is just 4y plus 2 times 4 is 8 equals 0 times 4 is 0. And now lastly, this negative here, we said we couldn't have a negative for that a value. So we got to get rid of a negative. So what I can do is I can divide by a negative 1 all of the terms, and that'll cancel out that negative. So that is now gone, and we have a positive 3x. And then with the next one, a positive and a negative, that's just negative 4y. Same with the next one, it's going to be negative 8. And then equals 0 divided by negative 1, that's just 0. Moving to the next thing here now, it says finding and graphing intercepts. So we've seen y-intercepts before and how to calculate those, but it says for the y-intercept, it is the y-coordinate of the point where a line or curve crosses the y-axis. So it's basically wherever it crosses on your y-axis. So this right here would be the y-intercept. And then similarly, the x-intercept is the x-coordinate of the point where a line or curve crosses on the x-axis. So that is where it crosses on the x-axis, so that would be that point right there. And the y-intercept, that's going to occur when x equals 0, right? This is positive x over here. If I come down, that's when x is 0. So that gives me the y-intercept. And similarly for x-intercept, it occurs when y equals 0. So when the height is down at 0, that's when it crosses the x-axis. So for that graph right there, the x-intercept is at 1, crosses the x-axis right there. And then y-intercept is 2 because it crosses the y-axis at a height of 2. So I'm just going to label those. This one right here, that is the y-intercept. And for short form, a lot of the time we just put y and then int. And then this one right here, that is our x-intercept. So anytime you need to find the x-intercept or the y-intercept, we got to do a substitution. If you want to find x-intercept, you'll just put in y equals 0 and then solve for x. And if you want to find the y-intercept, that's when x equals 0 and then you'll solve for y. So it's kind of opposite. If you want to find x, y is equal to 0. And then if you want to find the y-intercept, set the opposite, set x equal to 0. So we're going to do some questions now where we actually do that. So it says, for the following equations, find the intercepts and sketch the graph. So we're going to find the x-intercepts and the y-intercepts of this. So let's do x-intercepts here first. So that happens when y is equal to 0. So I'm going to change the y in here. It's going to change into a 0. So I'm going to have 2x plus 3 times y, but y is a 0, and then minus 6 equals 0. So timesing by 0, that's going to be gone. So I just have 2x minus 6 equals 0, and that's an equation that I can solve. So I want to get this x here by itself. So I'm going to add 6 onto both sides. These will cancel, and then I got 2x equals 6, and then divide both sides by 2, and you're going to get x equals 3. So this just gave us the x-intercept of 3, and that's when y is 0. Remember, it goes x and then y. So let's plot that point on our graph. We're going to go over to 3 and then 0 up or down. So that's right there. To find the y-intercept now, I'm going to plug in when x is equal to 0. So I'm going to have 2 times x, which is a 0, plus 3y minus 6 equals 0. So this is going to be gone. Then I just have 3y. I'm also going to add a 6 onto both sides right now. Those 6's will cancel. So I'll get 3y equals 6. And then just divide both sides by a 3, and you'll get y equals a 2. So we just got the point when x is 0, y is 2. Remember, it goes x and then y. So I'm going to plot that point now. So our y-intercept is up here at 0 and 2. So once you have those 2 points, you can take your ruler and then draw your line going through your 2 points. And then don't forget, at the end of your line, just make sure that you have your arrows there to show that the line just keeps going and going. Question number 2 here now. If you want to pause the video and try to do this one on your own, you can pause it and attempt this one now. So hopefully you tried to find your x-intercept and your y-intercepts first. Calculating those, we got these right here. So for the x-intercept, you're going to change the y into a 0. So y goes to a 0. That's going to be gone. So you're just going to have 4x minus 20. That's that right there. And then get the 20 to the other side. It's going to be positive 20. Divide both sides by a 4, and we get x equals 5. So that gave us the x-intercept. X is 5. Y is 0. So let's plot that point. We're going to be over at 5 and 0 up or down. Then for our y-intercept, that's when x equals 0. So now this is going to be a 0. So we're going to have 4 times 0. So 4 times 0 plus 5y minus 20 equals 0. 4 times 0 is going to be gone. So we just have 5y. And this minus 20, when I move it over, it's going to be positive 20. And then divide both sides by 5. So we get y equals a 4. So when x is a 0, there's a 0. The y is a 4. So let's plot that point. We're going to be at 0 and 4. And again, once you got your 2 points, take your ruler, draw your line through your 2 points. And then don't forget those arrows at the end of the line. I also have down here at the bottom a third example. So if you wanted to look at a third example or practice another one, you could look at that one, and there's the solution for that one. So lastly, we're going to look at the number of intercepts, and we're going to be talking about x-intercepts and y-intercepts. So there's going to be 3 different types of scenarios. So if you have a line that's at any type of angle, you're going to get 2 intercepts. It's going to have a y-intercept and it's going to have a x-intercept. If I drew, say, another line, again, just at any angle with any slope, so something like that, it's going to have a x-intercept right there, and then our y-intercept is right there. So anytime it's at some type of angle, whether that's positive slope or negative slope, it's going to have 2 intercepts. The next scenario is when it has 1 intercept. So you could have, say, a vertical line like this one right here, where it only has an x-intercept right there. Or you could have a horizontal line, something like this, where it only has 1 y-intercept and it's right there. So that is a horizontal line. So those are the kind of scenarios you could have for 1 intercept. And then there's one last scenario where you have an infinite amount of intercepts. So that means it's actually on your x-axis or on your y-axis. So if you had one like this, where it's literally right on the x-axis, that means it's having a bunch of x-intercepts, so it has an infinite amount of x-intercepts. Or you could have, say, a line on the y-axis like this, and it has all of these y-intercepts everywhere on here. There's an infinite amount. So that blue line actually has an infinite amount of y-intercepts. So that was the last kind of thing we were covering in this lesson. So again, just some reminders, general form. When you hear the word general, try to think army, all lined up nicely on one side, and then equals 0 on the other side. So our textbook questions for today are on page 365.